we'll get started. Archana is a data product manager at Women in Code and is a passionate advocate for women in technology. She is recognized as a fellow by the Python Software Foundation for her commitment to leveraging Python and AI in data science. She has delivered engaging talks at conferences worldwide and the Women in Code Connect and Scipy 2023. She has broad perspective on the role of AI and data across sectors. She has experience leading and thriving community in Python enthusiasts as a Women in Code Leadership Fellow, and is here to help you navigate and understand the complex world of large language models.
Thank you. Thank you so much for such a wonderful introduction. And again, thank you so much, everyone, for joining in. I know it must be really, early or late, wherever you're joining us from. So yeah, thank you so much for taking out the time today. And as usual, I hope you take away something from this presentation. I think the idea here is that, at the end of the day, we are going to come across these terminologies a lot. And one perfect example is that, most of you, I believe, are from in and around working, maybe want to work in data science or have been working in data science as such. And more of the world is starting to sort of use, like everyday people are also starting to use GPT, right? And people are not going to understand how it works very well. And oftentimes, they might hear that, oh, you're working in this field, and they might turn to you and be like, how does this really work? So I think the goal of this presentation from my side is to make sure that, you walk away with a bit more knowledge about this, so that maybe the next time someone stops you and asks you about this, you can explain it to them. And I think one of the goals why I want to do this presentation from a personal angle is to obviously learn more, but most importantly, try and distill this matter into something which is very, very beginner friendly. And why I'm doing that is that, there is going to be more and more content that comes on this topic, but not everything is going to be accessible to everyone, because they're going to feel like, oh, it's overwhelming. I didn't know some of the previous topics on this, or maybe I didn't read research papers to know more about it. But that's fine, right? We want to make sure as much as possible, as many as possible people learn about how GPT works. And one of the core things that in and around GPT, and especially using it and deploying it and actually making sure it works the way it works, is prompt engineering. So today, through this presentation, the goals are firstly to be able to, introduce prompt engineering. If I have time, I'll also go through the types of fine tuning. I know we didn't cover it in the last session, but if I do have time, I'll go back to it. So there's also introducing prompt engineering. So what exactly is prompt engineering? And one thing I think I heard Som saying very recently is that he goes like, prompt engineering is not an exact science, right? And that's a good way to put it. I mean, I think prompt engineering is something that you will end up doing one way or the other. It's more like recognizing it as a field. And obviously, even right now, you will find a lot of people having a lot of different opinions on whether or not prompt engineering makes sense. And maybe by the end of the webinar, you can also make a decision like that now, whether or not you think prompt engineering makes sense for you. So I think that's also important. Those design choices also is something I'll be giving you, is that I'll be telling you, oh, you come up with, these two, how do you come to decide that you actually need prompt engineering? And then most importantly, what are the types of prompt engineering involved? And again, this is something that you intuitively might be doing, but it's just now explicitly said so. And lastly, how to do prompt engineering using OpenAI API. So let me go ahead. So yeah, prompt engineering LLMs. And again, I'm trying to get into this habit of making comics. I think it's a fun way to put in matters around LLM. So, feel free to check it out. We also have it on our newsletter. We try to make small comics so that people have fun along the way. And yeah, let me go ahead. So just to recap our last presentation, as usual, I want to start off with some fun quizzes. So first quiz over here. And again, like, don't feel overwhelmed. Maybe you didn't attend the last session. So it's like, oh no, I don't know this questions as such. It's fine. I'm trying to keep it like very, very simple. Even if you can't follow along, that's perfectly fine. Again, like everyone's learning curve is different. So do not feel like, even it takes me time to understand topics. And so I would, like, I don't think anyone would think less of you if you learn differently. So take your time and learn. And if you cannot as well, reach out to us. We would be more than happy to help you with resources. So, okay. So first is like, imagine you are an LLM. You've been trained on on a large amount of general text data. Now you're supposed to assist a team of medical experts. How would you perform the best? Would you do that by using general language understanding to respond to their queries, by learning more about medical terms and conditions from a large medical data set, or by delegating the task to a human expert? So I want to see the chat, but okay, awesome. We also have a lot of people who are, yes, you're absolutely right. It is B. So it is by learning more medical terms and conditions from a large medical data set, because at the end of the day, our LLMs and our large language models like GPT know a lot about everything. But if you wanted to be experts in something, we need to make sure it learns something perfectly. And so, it fine tunes it and it learns more about that matter as such. And okay, the second question is, you're using LLM for your company's customer support, but your customers often use specific product related jargon. How would you improve the model's performance? Would you trust the LLM's general language understanding to deal with it? Fine tune the LLM on a data set that includes product specific jargon, or hire more human customer support staff? And yeah, awesome. Thank you so much, everyone, for, jumping in on the chat. I really appreciate it. And please don't feel shy again. It's not like, anyone knows what you put in the chat. It's only for you and your learning. So outside this group, don't worry. No one is going to know your answers as such. So feel free to use the chat. And so, yeah, just like a quick recap on what was fine-tuning LLMs. So imagine like you've spent years learning various languages and you've practiced speaking, writing English, Spanish, French, and many more. And you've become like great at recognizing the rules of grammar, the flow of sentences, and the meaning of words in these languages. This is similar to how LLMs are initially trained. They process and understand vast amounts of text data from diverse sources, learn the pattern, structures, and nuances of human language. Like you like you with your multiple languages, LLM can generate text that makes sense in various contexts. But now if you want to work as a tour guide in France, you may need to understand like specific culture, history, colloquialism that you didn't just learn by speaking the language, right? So that's called fine tuning. And that's where the LLM sort of fine tunes and learns some specific things. Like, for example, if you were a tour guide in France, it'll start learning specific thing about the French culture and French history. So that is why fine tuning is essential, because LLMs are great at general matter, right? But as such, when you move into a specialized field, you need these LLMs to perform well in a specialized task. And that is why we need to do fine tuning as such. So this is just a recap. And one more quiz before we, I think, jump on to prompt engineering. You've been using LLM for generating news articles, but there's an upcoming election that the LLM doesn't know about because it happened after the model's knowledge cutoff date. This means, like, for example, GPT right now has like 2021 September, right? The cutoff date. So that means after that, the model doesn't know any data. It was trained on all data before that. And you have like maybe elections coming in this year. So what could be your strategy? Use LLM as it is and add the election news manually. Fine tune the LLM with new data about the election. Wait until a newer model that knows about the election is available. And let me check out the answers again. Awesome. B again. Yeah, I know the B is a pattern here. But the questions are more to just refresh your knowledge, and so that, I give you like use cases around it. Because oftentimes what happens is that the more use cases and the more beginner friendly examples I give, I think like if you hear about it somewhere else, you might be able to relate to it. So yeah, So how do you like when to fine tune LLMs is also important, and this is like a nice flow chart that I had around it. It was like, does your task require specific domain expertise? If it does not, you use pre-built models. If not, you take and then you make sure, oh, do you have those compute and like time and resources to actually train your models? If you do, and then you seek to collect and acquire the data, and then you go ahead and fine tune the models. If not, you try to use the existing ones or try to prompt engineer, and that's what we will be looking into today. So let me not cover this because this will take a long time. Let me jump right into prompt engineering, because I want to cover as much as possible on prompt engineering today. And so, yeah, so prompt engineering and introduction. And I've taken this from this person's blog. I'll just go back to it. So this blog called Prompt Engineering by Lillian Weng. So that person has actually written it very well. And you should check it out. It's on GitHub. It's a pretty long blog, and there's also a lot of mathematical explanation around it, which I have removed. But I have like kept like at least that person has gone over types of prompt engineering, and that's what I have also covered over here. So what is prompt engineering, right? And again, like it's more intuitive than you think it is. There's obviously, I think engineering is too heavily used. I think the point here is that you can actually help your model get better, right? So imagine you're training like your pet to perform tricks, right? If you want your dog to sit, you just don't yell sit once. You repeat it several times and reward it for good behavior until your pet understands the command. So prompt engineering is similar. It's a way of teaching a computer program to respond to certain input of prompts. The better your prompts, the better the computer's output, or in this case, the model's output. So if we were talking in technical terms, and I know there's a lot of text on the presentation. Just to give a context here, I want to make sure that whatever I say is on the presentation as well for accessibility purposes. So yeah, you might see me reading off the presentation, but it's a bit intentional as well. So prompt engineering involves creating inputs that guide LLMs like ChatGPT to generate desired outputs. It's essentially for developers, allowing them to effectively use LLMs to perform tasks like text generation, question answering, summarization, translation, and more. The key is in understanding how these models process inputs and tailor those inputs to get the best results. So it's more like making sure you're giving your model proper prompts or proper text so that it understands what it might face in the real world, right? Like the customer support examples. So when exactly to do prompt engineering, right? Should you do it immediately, or should you like figure out when to do it? And I think those design choices are extremely important, because oftentimes we like, the more I've worked with industry and the more that I've been consulting as such, what I've realized is that a lot of people want to use new technologies for the sake of it. Like, for example, now you'll see an explosion of people like maybe LLM engineers and GPT based engineers or prompt engineers as well. Maybe their, like jobs will somehow increase now. It's also because people really want to jump on the wagon and try using new technologies. But oftentimes when that happens, you have to ask yourself this question: do I really need to do that? And that's where this design choice comes into play. So wait, okay, I think like I wrote it. Okay, let me do when to do prompt engineering first. I wrote when not to do prompt engineering before that, but let me cover when to do prompt engineering first. Okay, let us consider you have this parrot and you're trying to teach it to sing a specific song. I know that's very hard. I haven't trained parrots as such, but I'm pretty sure it's very hard. So you have to like firstly choose your words and which are prompts and instruction, making sure the parrot understands and responds exactly how you want. It might take time, a few tries, and some patience. So when to do prompt engineering in this case? If you want the parrot to sing a specific song, right? And if it's a song context, like you're entering the like the parrot for a song context, then you have to make sure the parrot like follows certain rules and guidelines. And if you want the parrot to sing in a unique rhythm or style it has never tried before, so that is when you need to do prompt engineering. But when not to do prompt engineering, right? And when you should let the parrot be. So like, you know, when it's happy chatter, if you're enjoying the parrot's random chatter in songs, background noise, if the parrot's noise is just meant to be relaxing background noise and doesn't need to be specific, then you probably don't need to go through the trouble of teaching it how to sing, right? And if you don't have time to teach the parrot a new song and you are content with whatever, then you choose not to do it. It's like something you're very busy and obviously it requires a lot of time. So those instances, you shouldn't be prompt engineering your parrot as well. And so yeah, so in terms of a technical term now coming out of the parrot example, like when to do prompt engineering is when you want controlled outputs. If you want more specific outputs out of your LLM, like your large language model, that's where prompt engineering is necessary. When there's complex queries, for example, you know, you require the model to understand like multiple context points and like something specific to a domain as well. And that those places you need to use complex prompt engineering. And finally, guided learning. So when you're teaching the AI to perform a new task or introducing new knowledge beyond its training, prompt engineering can help guide the learning process. And when not to do prompt engineering is firstly, if you have simple queries, right? If your interaction with the LLM is straightforward, you ask it like, what's the weather today? Or like maybe something which is very general, like, I don't know, who won the last FIFA World Cup? Like those things are like very general, right? Right. So those are like simple queries. And if you're trying to have open-ended conversation, very casual, right? Those places you don't need to do prompt engineering. And most importantly, if you have limited resources. And that's one thing you need to decide before you get in, because a lot of companies and projects as such, you'll be like, oh, let's go ahead, let's try this. But you end up realizing, oh no, this requires a lot of people to come up with prompts. If I can't come up with prompts on my own, can I use some tools for coming up with prompts? And those tools are obviously going to cost you money. And if it's not that, it's also the fact that it's going to require compute. So just realize that at the end of the day, it also comes down to the resources you might have. So now it comes to a question, like now you've gone through fine tuning, you might ask yourself, do I need to do fine tuning or do I need to do prompt engineering? And that's a very valid question, right? So firstly, do you need the model to perform a new task or behave in a specific way? So then fine tuning might be the best approach. But if you need the model to respond in certain way to a particular prompt, then prompt engineering might be sufficient. And do you have the resources, like the time, computational resources, data for fine tuning? Then you should get into fine tuning, because fine tuning again is like much more larger in the sense that you're taking all the data that this pre-trained model has, and then you're giving it new data. It's unlike prompts, it's going to be like much bigger. And do you have the expertise to design and test prompts? So this is very interesting and important, because, for example, let us go back to the scenario of the customer support, use case. At the end of the day, like, you want people to respond in a certain manner to certain questions, right? If you were a customer support executive. So like over time, and again, what happens is that you are going to have the public ask all sorts of questions, right? But you will have to make sure that you design these prompts around it. So you will have to take into consideration every possible scenario that the public can ask about the particular product, so that the customer support executive is able to respond to that. And while prompt engineering is generally like a less resource intensive than fine tuning, it also requires a good understanding of the model's functionality and a clear aim for your desired output. So I drew this diagram here, and I don't know if it's visible, but it's more like what we have already talked about. Like, firstly, identify your project's needs. If it's simple in general, then you don't need to do prompt engineering or fine tuning. Let me use the laser pointer. And yeah, and if it's complex and specific, then you need to evaluate your resources. And that's pretty important, because If you don't have enough resources, again, getting into this does not make sense. And then if you have access to large amounts of task-specific data and computational resources for training the model, then yes, go into fine-tuning. No, then access your capabilities and function. And do you have the capacity and time to iteratively experiment with prompts to guide the LLM output? So this means like it does, like you experiment as it's more like a trial and error. You try to see like if certain prompts work well with your model. If it does not, then you end up like going another route, right? So this is going to be like very time intensive process. And if yes, then go into prompt engineering. If no, then you need to go and like figure out some external assistance. And why this flowchart is very important is that what happens is oftentimes when it's good to interact with GPT and it's giving us the answer we need. And obviously it's creative. It sounds close to what humans need and like how humans write. But as soon as you take these models and actually put them into deployment and actually put them into real world use cases, you would need to fine tune or use prompt engineering. And at that instance, you will come down this pipeline where you will ask yourself this question at various points. And why this sort of like flowchart helps is that it helps you ask these questions beforehand so that you don't end up spending those resources down the line and then realize, oh no, I shouldn't have really done it because I didn't have enough of those to start off with. So that's where I think prompt, like, these design choices especially come into play. Now, let me get into talk into types of prompt engineering. Again, like prompt engineering, I think is a very fun topic because, it's something that you intuitively know it exists. And it's just about working on it, like taking that intuitive sense. And I know like a lot of people now are saying, oh, like if you're really good with like content creation and creative writing, you could become a prompt engineer. And I do believe there is like scope for people to upskill that way and become that, because at the end of the day, if you can end up designing these creative and good prompts to work with LLMs, that can actually help them perform better. And would love to hear if someone else also has other opinions. Again, that these are a few of my opinions around this topic. But yeah, let me jump back into types of prompt engineering. So firstly, like importance of prompt engineering again, right? The way you phrase your prompt to the LLM can greatly influence the response. So a well-crafted prompt can help the model understand the context better, leading to a more accurate and relevant response, right? And I know like I got this graphic as well. And I think like someone also wrote about this, the fact that, oh, AI is replacing your job, but maybe you can be a prompt engineer. So yeah, so moving into types of prompting, the first one is basic prompting. So basic prompting involves giving the model without any specific structure or additional context, like such as translate this English sentence to French or write a poem about spring. So the model uses its prior training data and its understanding of language to generate a response. The performance of the model is in basic prompting is largely dependent on how well it's trained and whether it can understand and accurately respond to an input or like to a prompt. And so there's two types of basic prompting. There's first one, which is zero-shot learning. So zero-shot learning involves feeding the model like directly without like any prior examples. So it's like zero shot, right? You don't expect the model to know a lot. It's just like something very basic, right? Like with GPT, you don't know what prompts were given before, but you know that, like you feed it some question and you'll get it. So those are like zero shot. And then there is few shot learning as well. So few shot learning is where you present it with high quality demonstrations on specific tasks before asking the model to perform a similar task. So let us say you're asking your friend, you're showing your friend a few examples of similar question and their answer before you're asking them a question, right? It's similar to how few shot works. You're giving them a few questions and then asking them from it. So it gives the model some context and guidance about what is expected. So few shot learning is a concept where the model is able to make decisions on prediction about unseen data after being given a few examples. In context of language models, few shot learning means giving the model a few examples of the task before asking it to complete a similar task. And so you're giving it, I would say, a little bit of guidance, right? Now there's like, you go deeper into it, like with better guidance. So first is like instruction prompting. So where is a method where the task requirements are explicitly stated in the prompt. So this method can save tokens, provide more precision, and reduce like ambiguity. So let us take an example here. So what if you were to write a story about a unicorn in a magical forest? You could simply prompt it by saying, write a story about a unicorn in a magical forest. This is like a simple prompt without any specific instructions. And again, like I think like somewhere it'll strike you, oh, I already do this with GPT, and that's what, it's quite intuitive right now. Is that what? But with instruction prompting, you could say like, write a story for a child, which is like 6 to 8 years old, about a friendly unicorn living in a magical forest filled with talking trees and magical creatures. The story should be fun, educational, have a positive message about friendship. So this is a much more detailed instruction prompt that guides the model to produce like a specific type of output, right? And there's like different types of instruction. So there's one is like in context instruction learning. So it's a combination of few shot learning and then instruction prompting. It involves giving the model multiple demonstrations across different tasks, and each demonstration consisting of an instruction, task input, and an output. So this is like showing your friend how to do a variety of tasks by providing example and asking them to do a similar but new task. So this is what is like few like in context instruction learning. To understand that better, I've given here another example. So if you look at your right hand side of your screen, it states like, let us say an active passive example, right? So the active example is the cat chased the mouse. So the passive is the mouse was chased by the cat. So give it another example. The chef cooked a delicious meal. A delicious meal was cooked by the chef. And then finally, it's like, now convert the sentence. So teacher teaches the students. So the passive is automatically something that the model understands now that you've given it a few examples already of what this structure should look like. So in this example, the language model has not been explicitly trained on not explicitly trained on converting the sentence, but you're providing it a few short examples within the prompt, and the model is guided to understand the pattern and the structure that you want. So you say, oh, this is the sort of structure that you want. Now find what is the next one. And this is obviously like a very low, I would say a low level example. You would also have like bigger examples and better examples of it. This is just something very simple. So in context learning is very powerful as it makes the model more adaptable to various tasks without the need for explicit retraining. It also allows for more flexibility in the ways that prompts are structured, which is especially useful in complex tasks where straightforward instruction might not be sufficient. And then there's chain of thought prompting. And I think you will read a lot about this because I've also been coming across this a lot, which is like chain of thought prompting. So imagine you're playing a game of 20 questions with AI, right? You wanted to guess that you're thinking of an elephant. Instead of making the AI guess all at once, you're giving it hints one by one. You would say like, I'm a large animal. Or like, it's a large animal. It lives in Africa and Asia. It has a long trunk. It has floppy ears. At each step, you're giving it a little more information that helps the LLM sort of narrow its guess. By the end, it has enough information to correctly guess, oh, you said it's an elephant. So it's like, teaching maybe like a child to guess, or maybe like your friend to guess like what you might be saying. So this is like a very simple and fun way to understand how chain of thought prompting works. And so chain of thought prompting is a prompt engineering where complex task is divided into sequence of similar tasks. Each task in the sequence provides the context for the next task. And in essence, they provide, so it's like a chain, right? Chain of prompts that guide the model towards the desired output. So let us say you want a hypothetical situation where this is like a much more, I would say, like better example, or like something that's more closer to what you might need. So let us say you want the LLM to reason about the hypothetical situation where a new infectious disease is spreading, and you want to know if closing schools would be a good strategy to slow the spread. This is a complex question that requires understanding of multiple domains, like for example, epidemiology, social dynamics, etc., and can't be answered directly with adequate context. So instead of asking the LLM directly, could you break down, you could break down the task using this chain of thought prompting. So you describe how infectious diseases are spread in a population, explain how school environments might contribute to spread of infection diseases, discuss the potential impacts on disease spread if schools were closed, and so on. And yeah, I'm sorry, there's a bit of drilling going on behind me. And yeah, I was a bit scared about it, but my apologies. I hope you can still hear me. If you can't, I'll be happy to repeat. Yeah, let me move on. So lastly, we have this thing called self-consistency sampling. So a good way to explain what self-consistency sampling is, like, imagine you're in a debate club and you're asked to prepare arguments for a topic, right? You wouldn't just come up with an argument and immediately present it. You'd probably like brainstorm on several different arguments, evaluate each, and select the strongest one to present to the club. This is essentially what self-consistency sampling does. The language model generates multiple responses, evaluates them, and then selects the one that is most self-consistent and makes the most sense in the given context. So this is, I think this is like, I think you could draw parallels to what this does inside GPT as well. I remember when I came across this talk by Andrej Karpathy, The State of GPT, and I say that, I know I keep mentioning the talk. If you haven't checked it out yet, you should. It's a really good talk. It's up on YouTube as well. And he talks about how, you know, even when you give GPT a certain prompt, right, you say, okay, come up with like a story for a magical unicorn in a forest. And it actually like goes down several paths. It's actually like evaluates which part makes the most sense and then comes to a conclusion. And sometimes it might take the wrong path, but sometimes, like most of the time, because it has such a large memory and such a large training data, it ends up giving something closer to what we want. So I think self-consistency sampling is maybe like somewhere you can draw parallels to it, is it's like almost mimicking that behavior, right? You take like each prompt and then you say that, you know, evaluate all these prompts before you come to a conclusion of which is important. So I think it's very useful for tasks where multiple plausible answers exist and the model needs to select the most consistent and reliable one. It helps to enhance the stability of the model's response and can lead to improved output quality. So yeah, I made this like very fun example, and don't worry, we're coming a little bit towards the end and Soham will take over with the demo. So like over here, like how to decide which prompt engineering technique to take, right? So I use this example of a customer service person, like you're designing like an ML system to handle customer service inquiries. So let us say you have this like, you know, and notice the figure on the right hand side. Let us say you have this task. Do you think it's simple enough? So let us say you are the company and you're given this sort of problem, right? An ML system to handle customer service inquiries. The company starts by assessing the complexity of the task. First thing you do is like, can a simple model actually handle it? So you customer service inquiries can range from simple inquiries about the products to services more complex problems that need troubleshooting. So these inquiries are not straightforward and simple. So we forget the simple task of it. So if it was simple, we could have used basic prompting, right? So now we move to something called token budget and precision requirements. The company has, you know, fairly generous token budget, let us say, but they want to ensure that the response to the customer inquiries are precise and helpful. So you want your system to be as good as possible. However, the diverse nature of the customer inquiries make it challenging to formulate a clear set of instructions for the LLM to follow. So they decide instruction prompting might not be the most suitable option and move on to the next. So what is the next over here? So the next over here is access to high quality demonstrations. So fortunately, the company that you are in has like years of customer service logs that include wide variety of inquiries and the corresponding responses. They can use this wealth of high quality demonstration to actually train the model. So that is where few shot learning comes into place, right? So you already have these examples and the model is able to understand what the prompts and output should look like. And then multiple demonstrations across different tasks. So if the company didn't have like a comprehensive set of service logs for a single task, but they have examples of different type of tasks, they can consider in context instruction learning, because here, like, you can also give it a certain set of instructions, and then through the certain set of instruction, the model comes out with an output. Right. And again, like, this is quite intuitive. I know, like, maybe it's like, oh my God, too much information has been given to me. But trust me, if you go through the content even once, you'll be like, yeah, it makes perfect sense. It's quite intuitive and probably something that you will do either way. And finally, we have like complex task and sequential learning. Assuming some of the inquiries that the company receives are complex in nature, right? Then they might want to employ like using chain of thought prompting, because then, with chain of thought prompting, you are like almost like giving it different sorts of prompts as well, and you're asking it to come to a conclusion with different instructions. So you're saying, okay, like, if this is given, this is what it should lead to. And finally, you have need for multiple outputs. So to handle inquiries where there isn't a single correct answer, like providing suggestions for product usage, the company could consider using self-consistency sampling. So in this, like, the LLM would weigh in the options, will be like, oh, does this work? Does this work? If this doesn't work, this doesn't work, maybe it needs to go to the next one. So that's where you'll have like self-consistency sampling as well that is involved. So throughout the process of your particular use case, you might have to use one or more types of prompt engineering. So let me now hand it off to Soham, and feel free to put your questions in the Q&A. Again, like, feel free to ask me if you want me to repeat something, because it is very loud where both of us are. And they are just drilling nearby. So again, my apologies.
Yeah, thank you so much. Let me just share my screen. Archana, could you stop sharing? Okay. So yeah, so you should be able to see collab notebook, and I've shared the link to the notebook in the chat as well. So what I wanted to show here today was how the output of LLMs differ when you do different types of prompt engineering, right? And the application that I'm trying to build it's similar to another application me and Archana are working on. It's called Speaker Scribe. What we do is we try to use AI and LLMs to generate talk proposals. So yeah, so this is how it works. So I'm using the OpenAI API for this. So to use it, you need to first install OpenAI. You need to then set the OpenAI environment variable. In my case, I'm using the GPT 3.5 model. But you can use the GPT-4 model as well. They've released the API recently. Okay, so the first one that Archana talked about, if you remember, is like the basic kind of prompting or zero-shot prompting, where you don't give the model any context, you don't give it any other information except for like what you want. And in this case, I want the model to create a talk proposal titled Large Language Models for Dummies, right? So that's the prompt, and I'm calling the API, and this is the talk that they generated. Also, it took around 8.5 seconds. You can see like this is not a bad talk proposal, right? The proposal has like an abstract. It also has the key takeaways. The abstract also kind of talks about pre-training, fine-tuning stuff that we've covered already. But I think, we can improve this a bit more. So the next step to improve this is to use something called few-shot prompting. What we do in few-shot prompting is we give it some context for previous talk proposals that other people have submitted. In this case, so you don't even have to give it like the proposal of the same talk, right? You can give it the proposal of a different talk, and what GPT should be able to do is figure out the structure of the original proposal and use that to generate a new proposal. So in this case, this is a talk that someone submitted to PyCon India. It's called Machine Learning Bias. And I've told in my prompt that, hey, this is an example for a talk titled Machine Learning Bias. So based on this example, can you create a proposal for a 30-minute talk titled Large Language Models for Dummies? So I did that, and you can see this proposal is really good, right? So there's the abstract, there's an outline for the talk. The outline includes like the major topic, as well as like what are the subtopics that you'll cover. It has like the time for each section. Although if you add it up, the total time is kind of like it's 35 minutes, I think, but that's fine. It also has other information like the motivation for the talk and why, and the motivation for submitting to PyCon, which I think is also great. But like I think GPT generated this because the example talk we gave also had it, right? It had the motivation for the topic and motivation to submit to PyCon. This may be something you want to provide to like when you're submitting a proposal, but sometimes you may not want to. Also, as someone who's like developing an application, this kind of an outline or this kind of a proposal, it's not really great because it's hard for us to parse through this. Let's say in my front end for the application, I want like a separate text box for the abstract, for the outline, and for the conclusion, right? I won't be able to, I'll have to write some extra code to be able to parse this information and then display it in the front end. What I can do instead is actually ask the LLM to generate the output in such a way that I can parse it. And I can do that using instruction prompting. So my prompt is more or less the same. I've given the same talk as the context. You can provide more, more context as well. And then, up until here, the talk, the prompt is the same as the previous prompt. But what I've added is some instructions for how I want the output to look like, right? So I want the output to have to be a JSON format with a title, abstract. I want the talk outline, and I want the talk outline to only contain the high-level topics as well as the time, right? Then I want like a detailed outline which expands on the talk outline, some background and motivation, and the target audience, which was not present in our original proposal, right? So I submit this, and it actually gave me the output in the format that I asked it to. So the title, abstract, talk outline, detailed outline, background and motivation, and target audience. You can see that with every iteration, like as we go more and more complex, like create more complex prompts, the time it takes to also generate the output increases, right? So the first prompt that was just like few shot prompting, it took 8 seconds. Few shot prompting took, I think, 13 seconds. And this one took, 17.5 seconds, right? So it's taking more and more time, which may not be good for your application, especially for an application like this, which is very creative, which is and where you don't want to disrupt, like let's say the person who's using it, you don't want to disrupt their flow state or something. 17 seconds is a long time for them to wait for the output to be generated, right? So yeah, so that's also something you should think about when you create more and more complex prompts. And then so what I think this also looks really good, right? But I think it can be improved. The part that I think can be improved is the detailed outline. The reason being, like, okay, so this is like it's just written a paragraph, which is not really great when you're submitting talk proposals. You want it instead to be bullet points. And I wanted to give more information, right? I mean, yeah, the introduction, it's kind of similar to what, like, there's no extra information, right? It's just like an expansion of the like what was there in the outline, right? So what I can do instead is something called chain of thought prompting. What I've done here is I've given like the same thing, the context. But what I've also done in addition is I've given the sorry, give me 1 second. Yeah, so what I've done is I've given the outline that was generated before, right? The same outline that ChatGPT generated here. And I've asked it to kind of like, so this is just like breaking down a large prompt and a large output into multiple outputs. So that's what I've done here. And you can see like now the outline, the detailed outline it's much better, right? But even though this particular prompt took around 10 seconds to run, in reality, it's actually 10 seconds plus, the 17 seconds it took to generate the previous output. So we're again, like the time is increasing more. And finally, self-consistency prompting, which I think it's like the most complex and really hard to get it to work. In fact, I wasn't able to get it to work here. So what you do here is you ask the model to create multiple outputs. So here I've asked it to create multiple outputs for the detailed outline. Right, I've asked it to create 2 outputs. And my prompt is basically like, hey, here is the original outline that you gave. Here are some other outlines that you generated. Is the first outline good? And if it's not, then, like, what is like the best outline among all the outlines that you've generated, right? And the output should be of the form like, is it consistent, and what the best outline is. This took 14 seconds to run, but 14 seconds plus like the 41 seconds it took to generate the multiple outputs, plus the 9 seconds it took to generate so right now you're at like more than a minute, right? Trying to generate just like the output, and you're also using a lot of tokens, so your cost is also increasing. But yeah, you can see the output. It says that it's consistent, but the best outline, it's actually not giving an outline. It's giving me like the whole talk again, which is not what we asked for, right? So yeah, so I guess what I'm trying to say is, in my opinion, I think chain of thought prompting, it's great. It works really well. It's easy to get it to work as well. Also, like, I think it's the right combination of the output being good, and at the same time, not spending a lot of time calling the API and not using a lot of tokens. In my opinion, and in my experience as well, building like different LLM tools, I think anything after chain of thought prompting it's really hard to get it to work. And also it gets more and more expensive and takes more time. So yeah, so I think that's pretty much it for me.
We just have a couple of questions. If you could take that, I'll just start sharing my screen.
Yeah,
And
sure.
I know we want to quickly like wrap it up as well. But yeah, just let me share my screen.
Yeah, wait, sorry. How do I stop sharing?
I should find the button where it says like where you get
Okay,
the
yeah.
mute button. Yeah, cool.
Okay, so the first question is, I'd like to know more about the difference between self-consistency. Okay, so the main difference with, so with few shot prompting, what you do is you give the model some context about how you want it to generate the output and how previous people, generated the output, right? And that gives the LLM a lot of context on how to make its output better, right? Better tailored to the ideal output. With self-consistency, what you're trying to do is you're trying to ask the LLM if the output is, if it thinks the output is generated is good and it's of the right format and it's factually correct and all of that. It's also a method to kind of prevent hallucinations and all as well. But yeah, it's really hard to get it to work, and sometimes it doesn't really prevent hallucinations. Sometimes what happens is the LLM kind of goes down a wrong path, and it'll like kind of keep going down that wrong path, and it's very hard to get it out of that wrong path. Okay, so I have another question. I've already generated an OpenAI key, but still see it. I can see the maximum usage is not reached when I set maximum amount before. I'm not sure what the context is for that question. Maybe you can ask, yeah, maybe you can put the question in the chat or maybe in Slack as
Yeah,
well.
sorry. Just quickly, I just want to, I think you can get it under answered. So this person is having issue with OpenAI API fine underscore tunes follow -I. And I think they've encountered
Okay.
some stream interruption, but I do believe it's from OpenAI side, right?
Yeah, I'll just check after I answer the next question, maybe.
Okay, cool.
When it is a matter of yes, no, true, false, then it belongs. No, not necessarily. The yes, no, true, false thing. It's just a way for me as a developer to know if the original answer was consistent or not. And if it wasn't, then I can just discard it and use the generated answer. Yeah. Yeah, I think that's it. Thank you so much.
Yeah. Would you have time to help Eugene?
Yes, I'll just take a look at that right now.
Okay, got it. Yeah, so just to quickly wrap our session as well, we are sort of creating this content on our own. So we just would love to have your feedback as to what do you think. And it's a small Google form. It's completely anonymous. So feel free to scan this QR code. And at the end, we will also give you access to all our previous slides. The idea is to just understand if these sessions are helpful, if there are ways to improve it. And again, like we are coming from an angle where we really want to make sure the sessions are as impactful as possible, and we are making the best use of your time. So just feel free to, drop us a feedback, and we would love to hear from you. And again, thank you so much everyone for joining in today. I know like it's right on the dot of the 11 o'clock time, but yeah, thank you so much for joining in today, and thank you so much for your time, everyone.
Thank you so much for that excellent presentation. Take care, everyone.
Yeah, thank you. Feel free to reach out to us. Thank you so much.
Yes, indeed.